we are using the coffee cup calorimeter that we used in experiment 9, the same one. And what we're doing is now we are doing the same thing that we did earlier, measure a change in temperature, but for a different purpose. So we are mixing two reactants, magnesium with hydrochloric acid to get magnesium chloride and hydrogen, and this reaction releases a certain amount of heat. So is it exothermic or endothermic? Exothermic, correct. And this heat Q that we are measuring, this heat that we are measuring is going to be measured using Q equal ms delta T. We are assuming that the solution is very diluted, okay? So we are not measuring the mass of the magnesium plus the mass of the hydrochloric acid to use this equation, but we're using just the mass of the hydrochloric acid. We're going to use the specific heat of the hydrochloric acid that is provided in your lab manual, and then we're measuring delta T. So what is that we are doing? We have, let me do this here. We have a certain mass of reactants that goes to moles of reactants that gives moles, actually that gives to our heat. So the heat is for the solution, and is measured with this equation. In order to figure out how much heat is released at a certain amount of magnesium, you have to calculate Q of the reaction over the moles of the magnesium they have used. Okay? So that's what we are doing. Is that clear?
Yeah.
Okay. And how do we get the moles? From the mass that we weighted. We are using the analytical balance to measure the magnesium. Now the magnesium that you had to weigh is not what is written in your lab manual. That is incorrect. You need to weigh approximately 2.5 grams, 0.25 grams of magnesium, or a strip of 15 centimeters. So here is the ruler. Please start by using the magnesium that is already chopped up. Oh, we don't have any more. So use the magnesium that you have in here, polish it, because we know that if the magnesium is oxidized to magnesium oxide, it won't react with hydrochloric acid when it's a metal. Then what we are going to do is we are performing a second reaction. Magnesium oxide reacts with hydrochloric acid. This is a powder, white powder, and it's kind of sticky. So when you weight the magnesium oxide in the boat, make sure that you really collect all of it, okay? Because some of it will stick to the boat. Some of it, you have to pour it carefully because some of it will also stick to the walls of the calorimeter, and so you have a wrong reading of temperature because some of it won't react. Also keep in mind that if you see that all the magnesium oxide didn't react, you have to repeat the reaction. The hydrochloric acid is our excess reagent in both reactions. So if these two are not completely consumed, that means that things didn't go well in your reaction and you have to start all over again. Okay, so in the second case, you're measuring, I think, about I don't remember. So, okay, so this is 0.25 grams of magnesium, or 15 centimeters of magnesium. So at the beginning you record the initial temperature of the hydrochloric acid, then you dump the magnesium into the calorimeter, start to stir, and the temperature will start to rise slowly. You are going to record the max temperature of the mixture, the hydrochloric acid and the magnesium. Then you discard the solution in the white bean, okay? You should have no magnesium left over. So let me tell you, you can use 50 centimeters of magnesium, but you still have to measure the mass. The other thing that you need to do is you need to repeat this entire process times 3, or enough time to have 2-3 readings of the delta T. They are consistent or precise, to better say. Okay, so the next step, this is part B, I made a mistake, is we're measuring 50 milliliter of hydrochloric acid. We use the granite cylinder. We don't have to be accurate because it's the excess reagent, right? Then we are going to put this in a calorimeter, take the temperature initial temperature of the solution, and then add, I made a mistake, sorry, I wrote this here, 0.25 grams of magnesium oxide in the boats, okay? And use the analytical balance because we need to know the 4 significant figures after decimal point. Then you're going to pour it in the calorimeter. Make sure that there is no magnesium oxide sticking to either the plate, the boat, or the walls of the calorimeter. And then you're going to record the maximum temperature, this time of hydrochloric acid and magnesium oxide. You rinse the calorimeter for both processes. You always rinse and repeat again, also in this case for 3 times. You discard always in the inorganic solution beans, the white bean. Okay, so now let's go 1 second to the calculation. So we are calculating the Q for reaction 1 and the Q for reaction 2, assuming, as I said earlier, that the solution is extremely diluted, okay? Then what we are going to do, we are going to calculate also in the second case, from the heat of the solution for this reaction, we are going to calculate the delta H, this is for reaction 1. For delta H of reaction 2 as Q calculated from the MS delta T, where the M is again the mass of the hydrochloric acid, not the hydrochloric acid with plus the magnesium oxide. You will see that if you add the mass of the magnesium oxide, the Q doesn't really change that much. So you're using the mass of the hydrochloric acid, the specific heat of the hydrochloric acid, the delta T of the hydrochloric acid before we add the reactant and after we add the reactant. And then we divide that times the moles of magnesium oxide. Okay, so we know the delta H. Remember that this has to be changed in kilojoules, because the delta H is measured in kilojoules per mole. Once we have done this for 2 reactions, we explained last time the Hess's law. And so what did we say? If I have a third reaction, of which I want to figure out what is the delta H, what do? If I have 2 reactions that I can combine so that the sum of these 2 reactions give us the final reaction, we don't need to perform a third reaction. So if I have this reaction, how do I change? How do I put together these two reactions, 1 and 2, so they obtain reaction 3? So I look at the reactant and the product. I see that in reaction 1, magnesium is on the reactant side. And for the properties of delta H, we said there is a state function. The delta H of the forward reaction is equal in value but opposite in sign to the delta H of the reverse reaction. And then the third thing that we learned was that the delta H depends on the state of the reactants and products and on what else? Is an extensive property, depends on the amount of reactants that we're using, right? So I can move, switch around this reaction so that some parts cancel out and the final product is what we have here. So this is reaction 3. To obtain this reaction, I'm going to write reaction number 1 as it is. Magnesium plus 2 molecule of hydrochloric acid, aqueous, that gives magnesium chloride, aqueous, plus hydrogen gas, aqueous, gas, excuse me. For the second one, I use the reverse reaction because notice that the magnesium here is on the reactant side. You see that here? The magnesium is on the reactant side and we want it on the product side. So I flip the reaction and I write that magnesium chloride aqueous plus water aqueous gives magnesium oxide plus hydrochloric acid. Okay, so if I consider these two reactions in the same way we have done before, we add this entire first part on the reactant side and this entire second part on the product side. But there are things that can cancel out, right? What is that can cancel? Remember that this is the same thing as writing equal. What can I cancel? The magnesium chloride cancel out. Anything else that can cancel out?
Hydrochloric acid.
The hydrochloric acid. Excellent. And the hydrochloric acid. So into the end, I have magnesium here, water here, and magnesium oxide here. So when we finish calculating for 1 and for 2 the delta H, the delta H of 1 will stay as what you calculated. The delta H2 has to be multiplied times the sign -1 times -1. Why is that? Because we flipped the reaction and we said that one of the property of delta H is that if the reaction is flipped, the sign of the delta H is opposite. Okay, so what you're going to do today to expedite the process is this. Each person in the team is in charge of one reaction. So choose who is doing reaction 1 and choose who is performing reaction 2. So you need the 2 of this setup, like this one. One person is going to add the magnesium to the hydrochloric acid, the other person is working with the magnesium oxide and the hydrochloric acid. So you're working independently and exchanging data. Okay? Does it make sense? In this way, we should be able to finish everything on time. If we don't, we'll continue next time. Okay? But I think you should be able to do that. Okay? Okay, any question? No question?
This is experiment 10, part B, trial 1. This is the magnesium strip, so record its mass to the appropriate number of significant figures. This is for experiment 10, part B, trial 2. This is the magnesium strip, so record its mass to the appropriate number of significant figures. This is for experiment 10, part B, trial 3. This is the magnesium strip, so record its mass to the appropriate number of significant figures. Okay. This is experiment 10, part B, trial 1. In here is 50.0 milliliters of hydrochloric acid. And this here is the initial temperature of the solution, so record it to the appropriate number of significant figures. Good. Okay. Now we're going to add the magnesium strips inside and record the maximum temperature observed. As you've observed, record its maximum temperature as its final temperature. Record the maximum temperature.
Okay.
This is for experiment 10, part B, trial 2. Inside we have 50.0 milliliters of hydrochloric acid, and this is the initial temperature of it, so record it to the appropriate number of significant figures. Okay. Now we're going to add the magnesium strips inside and observe the temperature change and record the maximum temperature. So as observed, record its maximum temperature to the appropriate number of significant figures. This is for experiment 10, part B, trial 3. Record its initial temperature to the appropriate number of significant figures. Now we're going to add the magnesium strips inside and record its maximum temperature as observed. So record its final maximum temperature as observed to the appropriate number of significant figures. This is for experiment 10, part C, trial 1. This is the mass of both the weighing boat and the magnesium oxide that we're going to be using. So record to the appropriate number of significant figures. This is for experiment 10, part C, trial 2. This is the mass of both the weighing boat and the magnesium oxide that we're going to be using. So record to the appropriate number of significant figures. This is for experiment 10, part C, trial 3. This is the mass of both the weighing boat and the magnesium oxide that we're going to be using, so record its mass to the appropriate number of significant figures. This is for experiment 10, part C, trial 1. Here we have the 50.0 milliliters of hydrochloric acid, and you're going to record its initial temperature to the appropriate number of significant figures. Now we're going to add the magnesium oxide to the solution. We're going to stir it, and then we're going to record its maximum temperature to the appropriate number of significant figures as well. So now record its maximum temperature to the appropriate number of significant figures. This is experiment 10, part C, trial 2. Here we have our hydrochloric acid in our apparatus, and we're going to record its initial temperature to the appropriate number of significant figures. Once it's recorded, we're going to add the magnesium oxide, and then we're going to stir and record its maximum temperature. Now record its maximum temperature to the appropriate number of significant figures. 1, 2, 3, go. This is experiment 10, part C, trial 3. Here we have our initial temperature of the hydrochloric solution inside. So record it to the appropriate number of significant figures. Okay. Now we're going to add our magnesium oxide. And then we're going to stir and record the maximum temperature. Okay. So now that I've tiered the balance, I'm going to weigh the weighing boats after each use. So this is the weighing boat for trial 1. Record its mass to find the net mass of the magnesium oxide. Okay. Now this is for trial 2. Record it and calculate the net mass for the magnesium oxide used. And this is for trial 3. Record its mass and calculate the net mass for magnesium oxide used.